Right, look over the sideboard, please and thank you. Actually, just look at Ireland. She requested yesterday. She's like, I just wish everyone would look at me instead, okay? That's actually what she said, the opposite. She's like, I feel like everyone looks at me, so it's weird, okay? So guys, look at the sideboard, but specifically don't look at Ireland, okay? Are we good? Okay, cool, okay. Throwback Thursday, the 11th of February, you guys will be able to use the triangle proportionality theorem and proportional relationships. Whew! That's a mouthful. Triangle proportionality theorem. We're starting out with it. Here's the theorem.
Oh, no.
If a line parallel to a side of a triangle intersects the other two sides, then it divides those sides proportionally. Let's dive into what that says. Okay, let's break it apart. Because I think it's pretty wordy, right? A lot of us see that. We might just kind of get wide-eyed and we're like, what's that meaning? Okay.
I see the conclusion of it.
If a line parallel to a side of a triangle. Okay, so we have a line parallel to a side of a triangle. Do you see that in the picture? Line EF is marked to be parallel to one of the sides of the triangle. Do you see that? Okay. If that line intersects the other two sides of the triangle, does this line that's parallel to the third side intersect the other two sides?
Yeah.
Okay. The if part is true. That means the then is true. You guys remember doing those if-then statements? Okay, the if is true, now the then is true. So, it, talking about this line, EF, divides these sides proportionally. Okay, proportion are two ratios that are equal. So, A to E, the top half of this, is going to be over E to B, the bottom half of this line. That's going to be equal to A to F, the top half of the other side, over F to C, the bottom part of the other side. That's what results from that. So because they're parallel and it intersects the other two sides, we could say this over this is equal to this over this. It measures. Questions on what that means before we start using it and applying it? It becomes a little more tangible to us. Okay, what does tangible mean? Okay. Okay. It literally means that you're able to touch it. Okay. But in this case, am I meaning the literal meaning? Okay, because you couldn't touch it. So what am I heard some other explanations. You're able to understand it better. It makes more sense to you. You're able to grasp it mentally. Okay. So instead of grasping it physically, I'm using it figuratively. Okay. What does figurative mean?
Like a figure.
Okay. Not literally. Okay. It's more of a comparison. Okay. So, right, okay, psych, cross-curricular, okay? So we're figuratively using that, okay? So we're able to grasp it mentally, okay? You can't actually grasp something that's a mental concept, okay? So, Aiden, do you have actually a question?
No.
Okay, so, find the length of the segment, okay? So if we want to find segment CY, okay? Well, let's look, we're going to have the same setup we have in this theorem. We have a line, in this case, YX, or a segment, that's parallel to the third side of the triangle, right? And it intersects the other two sides. So that's the F part. Parallel line intersects the other two sides of the triangle. So it divides these sides proportionally. So according to this, we can set up the proportion. 9 over 4 is equal to 10 over... we can call this whatever we want. What do we want to call this? Maybe not X, since we have an X here. Okay,
Let's call
we
it
have a Y. Z, okay, Z. We don't see a Z. There we go. Okay, let's pick something we don't see, okay? We normally don't have X as one of our points, but when we do, we want to avoid using it as a variable, because that could get confusing, right?
Why don't we use Bill?
So, this setup works according to the triangle proportionality theorem. This would be true. How... It slaps? I think so. Good old Backstreet Boys. How would we solve this to find the measure of Z, or aka segment CY? Saren? I would say cross multiply as well. 9 times Z is 9Z. 4 times 10 is 40. Divide both sides by 9.
Z equals 4.4 repeating. I looked it up.
4.4 repeating.
Yeah.
Okay. Does that check out?
Yeah, it's 4.4.
Okay. So, the length of the segment, we would say the measure of segment CY is equal to 4.4 repeating. I mean, I don't need that part, just the 0.4 repeating. And that would be our answer. Questions on how we got that?
No.
Now, we talked about how before there are other ways to set up proportions, right? Remember how we were setting proportions? I always said there's 4 ways we could do it.
Yeah.
Do we think we'd have other ways we could set this one up?
No. Well, yes, you can flip it around.
Okay, so you're just saying we could flip it around like 10 over z is equal to 9 over 4. That's true. I wouldn't count that as another one of our ways, though. Okay, well, let me ask this. Could we do, 4 over 9 is equal to z over 10?
Yes, it does.
4 over 9 z over 10. We're just saying let's do the smaller part of the side over the larger part this time instead, and then doing the same thing on the other side of the triangle. Well, if we cross multiply, do we still get 4 times 10?
Yeah.
Do we still have 9 times z?
Yeah.
So is that going to be equivalent?
Yeah.
Yeah. Is there another thing that we might see we could do?
Z over 4 equals 10 over 9.
I would agree. Z over 4 equals 10 over 9. Well, let's take a look at why this works. Okay, not only if we cross multiply 9z and 40 again, but horizontally z and 10, okay, well that deals with the same side of the triangle. Horizontally 4 and 9, same side of the triangle. Vertically z and 4 both deal with the same part of that triangle, the same section of it, okay? They're both dealing with the section toward the end of the triangle, okay, this direction to the left. 10 and 9 are both dealing with the same section of the triangle toward the right, okay? Are we seeing that? Okay, is there another one we could do as well? Yeah, Aiden, what would that be?
Okay, it would be z over. So, anyways, what I was going to say is.
Oh,
Hold on. Oh yeah, it is. It's z over 10 divided by 4. Z over 10 equals 4 over 9.
we have that one here. Okay, I wouldn't count that as a different one though, because we didn't just flip any of them. We didn't just flip around the equal sign. Okay, does someone else tell me what my other one would be? Okay, Saren.
I don't think this would work, but 10 over 4 and 9 over z over 9.
Okay, I'm going to agree with you that it doesn't work. Okay, 10 over 4, that falls apart vertically because 10 and 4, they don't have anything in common. They're not the same section of the triangle and they're not the same side. Okay, what about this? 4 over z. What about 4 over z? What could we do then?
9 over 10.
9 over 10.
There's more.
Okay.
I'm just gonna stick to the triangle.
All right, let's look at letter B. If I wanted to find the measurement segment PN, what could I now call that segment?
X.
Okay, we like calling things X when we can, right? Here I don't see a single good reason not to call it that. Okay, cool, you could call it cheeseburger if you want to write that out, or draw a cheeseburger each time. As long as you draw it well, I suppose. Now, do we have the setup for the triangle proportionality theorem? I think so. We have a parallel line or segment to the third side, and it's intersecting the other two sides. So it divides these proportionally. Can somebody help me with one of the 4 possible proportions we could set up? Okay, let's go with Saren.
5 over 2 is X over 3.
I would agree that works. Does anyone have another one they wanted to see if it works or not? Like they were thinking something else? Aiden.
3 over x equals 2 over 5.
That would work as well. Does anyone have another one that they were thinking, they were wondering if it worked? Okay. Kaya.
2 over 5 equals 3 over x.
That would work? Yep. Anyone else have another one that they were like, oh, does this work? Saren?
3 over 2 and x over 5.
Yep, that would work as well. Okay. So from here we would cross multiply. 5 times 3 is 15. 2 times x is
2x.
2x. Divided by 2.
X equals 7.5.
Yep.
So the measurement segment PN, 7.5. Questions on this?
No.
So we're still doing ratios and proportions. We're just doing with different parts of the triangle, right? So all of our same rules for setting the ratios up still matter, but this time we just have a different setup for the entire problem, a different premise, so to speak. Right? See you on the next page. Converse of the triangle proportionality theorem. What does it mean for the converse again?
Opposite.
Okay, opposite what? Opposite as in things are becoming the knots versions, or opposite as in the order? The order, the second one. Opposite of the order, okay? The opposite of like, not this would be the inverse, okay? So the converse is we're flipping it around. We're saying this time, if a line divides the two sides of a triangle proportionally, so this line is not known to be parallel now. We're just saying, hey, this line EF comes in, and these proportions are true. A to E over EB is the same as AF over FC. That's true. Then it has to be parallel. That's what follows. Oh, we now know the lines would be parallel. So we're just starting in the reverse direction. So here we'd be checking to see, is the proportion true, rather than solving a proportion and finding the missing side. Does that make sense? Or no? Okay. So on the other one, we were figuring out what side length would make this proportion true. Now we're going to say, we know the side lengths, and if the proportion is true, then they're going to be parallel. So do we know these lines are parallel right now?
No.
No, we're trying to find that they are. So we'll do that by working backwards. So what's a proportion we could set up to see if they are parallel? Proportion that we could set up and then verify, okay? Liam, what are you thinking?
21 over 42 equals 15 over 30.
Okay, that would be one of them that we could do. Did anyone have another one that they thought might work and they're wondering? Okay, Aiden, what are you thinking?
22 over 21 equals 30 over 15.
That would work. Does anyone have another one that they were wondering if it would work? Okay, Saren?
21 over 15, 42 over 30.
That would work, okay? So, we talked about how we have 3 different ways we can verify these. Does anyone remember one of those ways?
Angling.
You're talking about verifying if triangles are similar. We said, I'm trying to ask a different question right now. I'm trying to ask different ways we can see if these ratios are in fact the same, because I should put a question mark above there. They're saying, are they equal, okay? Kaya, what are you thinking of one of the ways?
Dividing
Okay, just type in what?
to make a decimal.
Okay, make a decimal. Divide it in the calculator. 21 divided by 42, 15 divided by 30. See if they're equal. If they're equal, they're the same. What do these both end up being? 0.5. Does 0.5 equal 0.5?
Yeah.
We know it's true. Does anyone have another way? Aiden. Simplify. 21 and 42 both simplify to what? 1 over 2. 1 over 2. Are they the same?
Yes.
Yep, the ratio is true. What's our other way?
Cross multiply.
Okay, cross multiply, and if you get the same answer on both sides, it works. So 21 times 30 would be 630, and then 42 times 15 would also be 630. Okay, so any of those 3 methods, perfectly fine. Okay, so because this proportion is in fact true, we can say, yep, as our answer, segment MN is in fact parallel to segment KL. Reminder, parallel can be done straight up and down or 2 slashes. So that's our answer. We verified it. Hint, 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 hint on a test. You would need to show me some level of work. Show me you made a proportion. Show me you verified the proportion's true before giving me your answer. Or verify the proportion's not true. Because if the proportion is not true, then it wouldn't work. Questions on A? Let's move on to B. A student states that UV, it should be say that says the, whoops. A segment UV must be parallel to segment ST based upon our given information. Do you agree? Why or why not? Okay, well, what do we have to do here to figure out if we should agree or not? Liam.
Proportionate.
Okay, we have to make a proportion between these 2 sections of the sides and see if they're true. Do we know any side lengths right now?
No.
No, okay. What can we call the side length of RU?
2.
Okay, X. Jerry. Okay. What can we call the side length of segment US?
Why? Why?
And
X.
I heard X and I heard Y. Why would X work?
So second X.
They're congruent. What can I call RV?
Why?
Okay. What can I call VT?
Why?
Why as well? Because once again, those are congruent. Okay, what's the proportion we could set up from this?
X.
Okay, Gage?
Yeah, y over y equals x over x.
Very good. We can set that up. Now, really, we could get into technicality saying which y is which, but it doesn't matter, does it? Okay, at the end of the day, vertically, the y's are the same. Are talking about from the same side. The x are talking about from the same sides. Horizontally, y and x, either way you cut it, would be the top section, bottom section. Okay, Kelly. Yeah, x over y works. Or y over x over y over x. Okay? Yeah, Saren.
Would x over y and then y over x work?
Nope. Because x over y would be going from this side to this side. Then y over x would be switching it around. Okay? That make more sense? Awesome. Great question. Okay? Any other questions on setups before we move on?
So
All right.
we agree.
So, y over y and x over x. Well, what would those both simplify to? 1. Because anything divided by itself is 1. You could also cross multiply and get xy is equal to xy, right? So, would we agree with the student?
Yeah.
I think we would. And then y? Well, you could say 1 equals 1. You could say y over y does equal x over x. You could say xy equals xy. You couldn't do a decimal on this one, but because we don't actually know the values. I guess I got behind the watermark. But does anyone need to know what this says that can't already know what this says? Doesn't already know what it says, excuse me? All right. Continuing on if you don't have questions. We're going to find an unknown height using similar triangles, okay? Hey, we've actually already done this. We're just putting it into word problems. Straight up. Okay? If it was warmer out, and not like literally single digits, excuse me, we would actually go outside and like we could actually find this out. It's pretty cool. We could like go to the flagpole, and like last year we had like a somewhat nicer day at this time in my honors geometry, and so we actually went outside to the flagpole and like figured out how tall the flagpole was without actually measuring the flagpole. Pretty cool stuff. Okay, Liam.
You can do it in here with the window if you just turn off all the lights.
And do the shadow?
Yeah.
Yeah, if the shadow would cast correctly, maybe, yeah. We'd have to figure out if we can know the shadow or not. We'd have to stand by the window too. Maybe. Yeah, I might be able to try that. Yeah.
We did this in Mr. Wallace's class.
Really?
With the water tower.
Oh, the stupid water tower.
Yeah, because we stood on the basketball court out the back of the school, and then we like measured how like the shadow from the water tower to here.
This is what he did before he left, too.
Yeah, he left
Oh.
like, right after.
Yeah, yep, that's what that means.
Maybe like 2 or 3 hours.
Yep, that's definitely what that means. Okay. We're going to call this indirect measurement. Does anyone know what we're calling indirect measurement?
Because we don't, it's not.
Not
It's
direct.
Because
not
it's
direct
not a
measurement,
direct
it's up.
measurement.
Because it's not a direct measurement. What would a direct measurement be of something?
Putting a ruler on something.
Putting a ruler, a tape measure to something, right? And saying, oh, this is this long. Okay? Yeah, this is 1 foot. Okay? So indirect measurement involves using the properties of similar triangles to measure heights or distances that are too great to be measured directly. Where do we use this? Mr. Costle? Well, this could be used in surveying. Okay? People that survey a land and say, okay, what does this land look like? What does the feature look like? What does this town look like? How tall is the water tower so we can do maintenance on it?
He's all gonna leave us.
Different things like that. Okay?
Why would you say water tower if you weren't gonna leave?
All right. So, so we use properly similar triangles to measure heights or distances that are too great to be measured directly. It'd be pretty hard to hold a ruler up to the water tower.
I mean, you could do
Kelly.
I'm pretty tall.
Are we going to use the Pythagorean theorem?
We actually won't. Yeah, great question. Pythagorean theorem formally comes next chapter. Example 1. In order to find the height of a palm tree, my parents love palm trees. Okay, my parents love tropical places. They're the classic old people to where they love vacationing and going to tropical places like cruises, Florida, you name it. Okay. Anyway, so to find the height of a palm tree, you measure the tree's shadow. BC is going to be the shadow. At the same time of day, you measure the shadow cast by a meter stick that you hold at a right angle to the ground. Find the angle of the tree, or find the height of the tree, excuse me. So there's a sun up here. Let me draw it here. There we go.
Perfect sun.
No, I'm not trying to make this more complicated.
Yes.
Suns don't have that many rays coming out of it.
Not that you can see.
A lot more.
There's only 3 on each side.
Not that you can see.
It's actually 6 on each side.
Fine.
Does a circle even have a side?
Yes.
It has one side.
It has.
Yes, very much.
Is that much more better?
That is much more better.
Okay. Hey, do we know right now if these triangles are similar?
No.
No.
Were we told they were?
Yes.
No.
No. We weren't.
Can you make them
Okay. We're not told. Okay? What's happening is there's a shadow at 7y, or excuse me, at zy, I call it 7. There's a shadow at CB. We know they're both at right angles because the meter stick specifically told us at a right angle. Palm trees typically are going to go at a right angle to the ground.
If they don't.
Okay.
It depends if a storm came through recently.
Okay? But typically, right?
Or how many coconuts
Okay.
it has on each side.
Okay. We're going to say typically they're going to be at a right angle. We're going to assume this is at a right angle, okay?
Alright, so
The sun is going to shine onto this palm tree and not onto the meter stick, right? And it's going to create the shadow here. What do we know about angle A and angle X?
They would be similar.
You can proportion.
What do we know about angles A and angle X? Saren, what are you thinking?
I was about to make it more complicated.
Okay, what do we know about angles A and angle X? They're congruent. Because the sun is going to hit it at the same angle, regardless of the height of the object. Because the sun is so far away that the slight difference in height comparatively from a tree to a meter stick or a water tower to a person even, because of how far the sun is away, it's going to really hit it at the same angle. The difference is going to be so minute, it won't even matter. Minute means very small.
no, wait.
So these angles are going to be congruent. What? Did I hear how do you spell minute? Minute's spelled the same as minute. It's really quite annoying.
But you have to have the accent version.
Yeah, it's like read and read are the same but spelled differently when you're talking about reading in the past tense. Okay? It's so silly, okay? Yes.
I have a problem with this.
Okay.
With what?
I think the leaves obscure the angle.
Sorry, say that again?
The leaves obscure the angle, so we won't be able to measure like where
Potentially. But there would be probably a part of the palm tree where you could figure out where the actual top of the tree was. Saren, would there be a part of the palm tree where maybe there isn't a leaf on one section and you could find the shadow of that part?
But then you'd also have to measure them in the exact same place, like under 15 minutes. You'd have to cut down a tree and like throw it away or something. Like put meat in
Or you didn't.
No, you just have to find the spot where there maybe isn't covered in leaves, or maybe you cut off a leaf. You create a spot. What was that?
How do you measure the meter stick?
It'll be the same.
Well, the meter stick is going to be the same time of day or within a minute of each other. So once again, the difference is going to be so small. Because if it's a different time of day, the sun's going to be a different place in the sky or compared to us. And so the angle would be different between them. But it specifically says at the same time of day. So it covers that basis.
Trust this or not?
What?
It's theoretical.
Yes, we trust the setup.
Okay.
Okay, so we know they're both at right angles. We know that these angles are congruent. So do we know the triangles are similar now?
Yes.
By what? Angle, similarity. So we know the triangles are similar. So what can we do since we know the triangles are similar? Can we set up a proportion now?
Yes.
Definitely we can. Okay, can someone tell me a proportion we can set up to solve for this?
7.2 over 1.6.
Okay, equals what?
X over 1.
I'd agree. X in this case is our AB, the height of the palm tree, okay? So 7.2 over 1.6, it works vertically. We're talking about the corresponding sides of the shadows. X over 1 works corresponding sides, height of the palm tree, height of the meter stick. Horizontally, 7.2 and X, talking about the palm tree. Horizontally, 1.6 and 1, talking about the meter stick. Questions on the setup? From here, do we know how to solve a proportion by now? I hope so. If not, you might want to talk to me. 7.2 times 1 is 7.2. 1.6 times x is 1.6x.
I'll do it.
Divided by 1.6.
What are you 4.5? It's 4.5, right?
Yes, it is.
4.5 what?
Meters.
Meters. This palm tree is 4.5 meters tall. Questions on that?
Actually, the angle would be the exact same because stuff is something.
One is and how far away it is too. So it's technically like if you were to go to like they're going to be technically slightly different, but it's such a small difference. It wouldn't matter in your calculation even.
Hold on, let me just spam zeros and see how far I can go.
What was that?
This is something I just found out, but if it's 1, can't you just take the bottom two numbers and then divide the smaller one?
So actually, it's not necessarily because it's 1, but what happens here is because the variables on the top, you can multiply and 1 is the same thing, right? And so you just take 7.2 divided by 1.6 and get it. So whenever the variable's on the top, you can multiply these two and then just divide by whatever's on the bottom, because the variable's already on the top. That's something I covered a few days ago as well, but then we kind of kept going with this method, because it works all the time. Yep. All right. Number 2. Sid is 72 inches tall. How tall is that in feet?
3, 4, 5, 6.
6. We got there eventually. Okay, 6 feet. To measure a flagpole, Sid stands near that flag.
Who names your kid Sid?
Okay, why is it important that Sid stood near the flag?
Sid the sloth. Oh, no.
Toy Story.
Yeah.
Wait, sorry, Max is answering this question, guys. Why is it important that Sid's near the flagpole?
Then the shadow gets taken away.
Yeah, the sun will hit the Sid and the flagpole at the same angle. Because would it work if there's someone's here and someone's maybe in Korea?
No.
No. Okay, some might not be out at the same time. All right, Sid's friend Miranda measures the length of Sid's shadow and the flagpole shadow at that time. So, once again, we have the sun up here. Okay, so look at that. Oh, look how pretty that is. Okay, so we could have some grass over here as well. You know, we could draw Sid in here. We could have Sid over here being 72 inches tall.
Look how tall he is.
He's so tall. He's a long boy. It's just 6 foot even.
He's got a long torso.
A long boy with a long torso. Okay. All right. So anyway, let's erase Sid. All right. Do we know these triangles are similar?
Yeah, it is.
Okay, we can prove that pretty quickly, I think, by saying, okay, same time of day, same area. Those angles are going to be this congruent. Once again, triangles are similar by angle similarity. So now it's a proportion we could use to find the height of the flagpole H. Okay, Dom, you want to help me with this one? You want to help me with this proportion?
Oh, okay. 48 over 128,
Cool.
and then 72 over 8.
Cool beans. Could we reduce here before we cross multiply? Sure, or you can not if you want. It doesn't matter. Okay. 48 over 128, what goes into both? 2?
Yeah,
Cool.
2.
24 and 64, we're going to be here for a bit. What goes into 24 and 64?
4.
Okay, 4 goes into both. 6 and... What am I thinking? 16, thank you. What goes into both?
2.
2, okay. 3 and 8, okay, there we go. Now we cross multiply with 3 over 8 and 72 over h. 3h is equal to whatever 8 times 72 is. I believe that's 596. No, 576, excuse me.
How do you do that?
How did I do that?
Did you take calculus?
Well, I did, but that's not...
So that's the reason.
Yeah, I did 8 times 7, 56, added a 0 for 8 times 70, and then did 8 times 2 and added 16 to the 560. Yep, exactly right. So now we divide both sides by 3, and h is 192 what? Inches.
By not simplifying, I did the long division.
Yep.
The big multiple.
Yep. And you still get the same answer, right?
I did.
Good.
That's
too long.
I used a calculator.
You
Okay.
need to put in
A
miles.
calculator.
I said
Okay.
calculator.
Questions on that?
Oh, we're almost done.
Okay. Last page of these notes. In real-world situations, you might not be able to measure an object directly because there's a physical barrier separating you from the object. You can use similar triangles in these situations as well. A hiker, someone's hiking, wants to find the distance D across a canyon. So this is across a canyon X to Y right now, believe it or not. Okay, so we kind of like could tip it, and X to Y is the distance across the canyon. This hiker, she locates points as detailed in the picture below. Okay, wait, are these similar triangles?
Yeah.
How do we know? Vertical angles. Angle WZV and angle XZY are vertical angles. They're always congruent. Now these triangles are similar, by angle similarity. Now, could we set up a proportion?
Yeah.
Okay. Anna, what would my proportion be? What would a proportion be, I should say?
600 over 400
Cool.
equals 327 over 8.
Dope, that would work. Okay, there are a total of 4 options that would work again. That's one of them. Here, we could simplify. What's the trick with those zeros on the left-hand side? Boom, 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 boom. As long as you're doing even the same number on the top and the bottom, we're good. Okay, it's like you just divided the top and bottom by 100. 6 divided by 4, 3 and 2. That makes your life a little bit easier, I hope. Cross multiply this. 2 times 327.
654.
Very good. 3 times D.
2, 3.
3D. It's like you have the glasses.
I do.
Like his.
Ooh.
218.
D is what?
218.
218 feet. Very good. My question then would be, whose feet? Okay. So you guys know how I asked this question earlier, what would you change if you were in my shoes? Last class, one of my students was straight up like, they just asked me out of nowhere, Mr. Cross, what size shoes do you wear? I'm like 10, 10 and a half. First thing I would change is the shoes, then they wouldn't fit me. And I'm like, my goodness, that is good. I didn't think of that. You would change your shoes too?
Yeah, I would
Yeah.
change it to my own shoes.
Yeah. And I'm like, my goodness, that is clever. So, all right, continuing on. Give me a thumbs up. How are you guys feeling about these? How are you guys? Thumbs down, thumbs down, thumbs up, thumbs down, thumbs up, thumbs down. All right, we're done with this.
I have 3 facts for this snack.
Dude, they're
Your
no.
raisins don't smell like me.
Okay. The water is the cheapest.
Don't do numbers 10 and 12. Reminder: test is on Fun Select Friday next week.
Don't do 10